Well, let's look at a clue. In Japan, over the last 100 years, they have had calorimeters mounted on the surface looking up at the sky to see how much sunlight actually reaches the calorimeter. And they measure it, and they keep a record of it. And if you plot that record in red against the temperature in blue, what you notice is there appears to be a correlation between the two. Now, correlation does not necessarily imply causation. We've already seen that. But there is at least a reasonable understanding that we may be looking at something genuine here, because if you have an increase in sunlight, if you go out there and there's no clouds, it's hotter than when there are. And there's the clue. Perhaps it's something to do with the clouds. So when I saw this graph, which has not yet been published, you're among the first to see this, I thought, right, I'm going to have another look at this. And so I trawled back through the literature, and this is what I came across. Now, this paper was written in 2005 by a satellite nerd named Pinker. He is wholly unconcerned with the global warming debate. It's as though he lives on another planet. He lives for verifying whether satellites are doing their job. That's what Pinker is all about. And so he had a look at the satellite record from the International Satellite Cloud Climatology Project and from the Earth Radiation Budget Experiment satellite, and he compared that with data sets on the ground. And what he found was this, that there was a significant, naturally occurring decline in cloud cover between 1983 and 2001. And during that 19-year period, the radiative forcing, in other words, the extra amount of radiant energy reaching the surface and then getting back out into space, as a result of that loss of cloud cover, was 3 watts per square meter, which is quite a lot. In fact, you aren't going ooh and ah, because you don't realize quite how much of a lot it is. Because according to the UN's mathematics, probably overstated, the entire radiative forcing from all human-caused greenhouse gases from 1750 to 2005, a period of 255 years, is only 1.6 watts per square meter. So here you have this enormous effect from a reduction in cloud cover. Just over that period, when, what did we see? We saw a significant warming. So what we know from this is that something like 4/5 of the warming over that period in the satellite era, when we can work out what caused it, was in fact caused by a change in cloud cover. And from that, we can do a little sum, which I won't explain. I'll just test you on it later. And you'll see, here we are. The measured bottom line is that the change in temperature, that's what we call delta T up at the top there, is the climate sensitivity parameter lambda times the change in radiative flux at the Earth's surface, what's called the radiative forcing. And you'll see that it comes out at just 0.43 Celsius degrees, but the UN predicts that if you double CO2, it's not going to be just 0.43 Celsius degrees, it's going to be 3.26. Very nearly 7.5 times too big. Now, if you take away that exaggeration by the IPCC of the warming effect of CO2, then you take away the problem, because half a degree of warming, when we double CO2 compared with now by the end of this century, is simply not going to matter. It's completely and utterly harmless. And that's the end. That's all you need to know about the science. Now, this particular calculation is not yet in the peer-reviewed literature, but I hope that it will be shortly. When it gets there, there are going to be white faces all through the IPCC, and I, for one, will be laughing all the way. Now, how do we check it? We're going to check it now very quickly. First of all, we could mount new thermometers and calorimeters side by side in rural regions all around the planet, and on ships and on buoys floating around the oceans, reporting by satellite and diagnosing themselves to make sure they're working properly, they haven't got a barbecue underneath them, as some of the US stations have actually had barbecues lit underneath them for years. And therefore you get global warming. Well, gee, that's that really is man-made global warming. So let's look at some of the reasons why the UN is getting it wrong. First of all, its conclusions are not based, as mine are, on actual real-world measurements by satellites and temperature stations of what is actually going on in the climate. They're based on Xbox 360s. They sit there with glazed expressions on their pimply teenage faces, and they play, and they play, and they play, and they make up completely meaningless models. Here's why we know that models of the future evolution of the climate cannot work. This has been proven. Now let's just talk a little bit about proof in science. Now here is a complete proof without words by Aryabhata, the distinguished Hindu mathematician of the 5th century, of Pythagoras' theorem. The square on the hypotenuse, the yellow one on the right, is equal to the sum of the squares, the two yellow ones on the left, of the other two sides. And you have 4 of the right-angled triangles in question in each of those two frames. Deduct those, and you can see, just by looking at it, that the two are equal. And that, believe it or not, is a complete, formal, rigorous proof. It's the simplest in existence. Here is my own, slightly less immediately intuitive, but nevertheless, I think, rather clever proof of Pythagoras' theorem. Come on, let's have a cheer for it. Yeah, yeah. And there are things that we can prove. And what these bedwetters have tried to do is to try to say that we can prove things about the climate with 90% confidence that we simply can't prove, and here's why. Because the climate, it is now known, and has been known since 1963, is a rather peculiar object when expressed in mathematical terms. It is a chaotic object, and that word has a particular meaning in mathematics. In view of the inevitable inaccuracy and incompleteness of weather observations, precise, very long-range weather forecasting would seem to be non-existent. That's Lorenz's great paper of 1963 in which he founded chaos theory. And he said, because the climate is chaotic, because you can't know its millions of initial variables to a precision that would allow you to predict exactly how it's going to behave in the future, once you go more than a few weeks out, all bets are off. Ask our Wet Office, they keep getting it wrong. Now, here's a really simple chaotic equation with essentially only one initial parameter, the complex number c. And I have assigned to that complex number a real part and an imaginary part, which are specified there to something like 16 decimal places. That's a very, very high degree of precision, certainly totally unattainable in the climate. And now we're going to look, you'd think, right, this is going to draw a particular region of what's called the Argand plane, and it's going to draw a pretty simple picture, isn't it? Because we've got a very simple equation. Here's the picture we might expect it to draw, something nice and simple like the Maltese cross there. Well, here, now you're going to watch the screen very carefully, because this is very pretty and it's also rather remarkable. This is what that simple equation actually draws, and I swear this is not a work of art by me. This is a work of art by he who invented mathematics. Here it is. Isn't that astonishing? That, from that simple equation, f of x maps to z squared plus c, c being a complex number. That's what the picture comes out at. And there's no way that I could have known that if I had changed just the last 4 digits of those 16, to which I specified the value of c. I would have got a completely different picture. If I'd added 1 to each part of the value of c, there would have been no picture at all. That is how sensitive a chaotic object in mathematics is to a tiny perturbation in its initial conditions. And now you imagine how difficult it would be to do that with the climate. That's why Shunichi Akasofu here, who's a very distinguished scientist whom I had the pleasure of meeting earlier in the year, or last year, he is the man who worked out how the aurora borealis works by nicking a NASA plane and borrowing it for 48 hours and chasing the aurora around the planet. Wonderful paper that he wrote as a result of it. He says you can't just use a computer to tell you that the greenhouse effect is caused by us. And he says also that the very result we're looking for, which is how much warming will you get if you add CO2 to the atmosphere, is something we tell the models before we set them to work. They don't tell us, we tell them. And that's known as the argumentum ad petitionem principii. It's the circular argument. You start by assuming a premise and then saying that premise is also the conclusion. That's not an argument, but that is the argument on which the entire case of the IPCC is ricketily based. A few other problems. Here's what's happened to the sun over the last 300 years. Remember, we've had this 300 years of warming. The sun has gone through, these are sunspot cycles here and how active they are. This is Hathaway et al., 2004. This is a NASA solar physicist of great eminence. And he shows the Maunder minimum between 1645 and 1715, when there were virtually no sunspots on the sun. Then to a grand maximum in the last 70 years of the 20th century, during which the sun was almost more active than at any time in the last 11,400 years. So you've gone from an 11,400 year minimum to a maximum in just 300 years. And it's no particular surprise that there has been global warming for those 300 years. Here's that graph again, showing the correlation between the amount of sunlight hitting the surface and the mean surface temperature. So the sun could have something to do with it, which the UN doesn't like to believe in.